everyone. Today we are going to discuss about corona. Please note down this corona is different from corona pandemic. This is basically electrical corona. What do you understand by corona phenomenon in electrical transmission line? This phenomenon basically related to electrical transmission line and it is associated with ionization of surrounding air of the conductor, and it also produces ozone gas with some hissing noise. This phenomenon is known as corona effect in transmission line. What are the factors affecting corona phenomenon in electrical transmission line? Here we are interested in knowing what are the factors which affect corona loss or corona phenomenon. First is electrical factors, second is atmospheric factors, and the last one is factors connected with the conductors. In coming slides, we are going to discuss all these factors in detail. Is it desirable? Not at all. Overhead line corona. Let us consider a single phase transmission line with radius r. Further, you can see two conductors and they are separated by a distance d, where you can clearly notice the distance d is very high as compared to the radius r. Further, we need to assume here charge density, that is shown by small letter q, and here we are interested in determining electric field intensity at point P, and that is given by this expression. I think you are aware about Gauss theorem, and this can also be determined by Gauss theorem. Now let us simplify this expression by taking q upon 2 pi epsilon naught as a common factor. Further, let us determine voltage difference between conductors. This expression is used to determine voltage difference between two conductors, and limits are taken as d minus r to r. So, having solved the expression, we obtained this equation number 2. Further simplifying this expression, and we have this expression for voltage, that is q upon pi epsilon naught log d upon r. Now, gradient at distance x from conductor A. So, after simplifying this expression, we have the equation number 4 as a final expression. Now, our interest is to eliminate q in these two equations, equation number 3 and equation number 4. So, substituting the value of q from equation number 3 into equation number 4 and further simplifying this expression. Now we have equation number 7. Now you can see that the term V dash is V upon 2, and that is the voltage of one conductor with respect to neutral point, that is the middle point of the two conductors. In case of three phase system, the phase voltage is VL upon root 3, where VL is line to line voltage. Now, an exercise to all the students. Please, you need to think what is the maximum value of the field intensity in equation number 8. Hope you will obtain this expression. So, equation number 11 is V dash upon R log T upon R, and arranging the terms as it is shown in equation number 12. This equation is very important where no factor related to weather or no factor related to the conductor surface are included. So it is very simple expression without including any weather and conductor related factors. Please think on following questions. What is critical disruptive voltage? What is dielectric strength of the air at NTP? Or you can say temperature at 25 degree Celsius and 76 centimeter on mercury scale. What is stroboscope? Impact of temperature, pressure and surface irregularities. So here a factor related to weather correction is included in field intensity term, that is G naught, and it is modified as G naught dash, and that is delta times of G naught. So this factor delta is well known as weather correction factor. In the expression of this weather correction factor, we have B, that is barometric pressure, and the term T stands for temperature. So this gives an idea about weather correction. Now, this term is included in voltage expression. Now, let us include the term related to surface irregularity. So, we always know that the conductor is exposed to different weather conditions. Practically, in field, we use ACSR conductors, and the cross section of such a conductor is series of arcs of circles, each of much smaller diameter than the conductor as a whole. Therefore, the potential gradient for such a conductor will in consequence be greater than for the equivalent smooth conductor, so that the breakdown voltage for a stranded conductor will be somewhat less than for a smooth conductor. The irregularities on the surface of such conductor are increased further because of the deposition of dust, dirt on its surface, and the breakdown voltage is further reduced. So, this surface irregularity is also included in expression of equation 15. So, this equation number 16 includes both the factors related to weather and conductor surface. Electric field intensity for visual corona. So, this expression is used to determine the field intensity value for visual corona. So, further, you can notice the corresponding value of visual corona, and that is shown by equation number 19. Actually, the voltage applied corresponds to the critical disruptive voltage which we seen in last slide. The corona phenomenon starts but it is not visible because the charged ions in the air must receive some finite energy to the cause further ionization by collisions. For a radial field, it must reach a gradient at the surface of the conductor to cause a gradient higher than the previous one, so that a finite distance away from the surface of the conductor, and that is included in this expression for visual corona. Now, surface irregularity is also included here. As we know, the surface of the conductor is irregular. The corona doesn't start simultaneously on the whole conductor surface. However, it takes place at different points of the conductor, mainly those points which are pointing, and this is known as local corona. So, equation number 20 includes this surface factor. Further, substituting the value of dielectric strength of air. Students need to write all the practical values of surface irregularity factor M. Students need to write all practical values of surface irregularity factors M. Corona loss is a very normal question comes in the mind of all students. How do you measure corona loss? So this arrangement is used to measure corona using Peake's expression. So this expression of Peake gives an idea about approximate value of corona loss. Further, students are required to identify various terms involved in this expression. This expression is capable to tell you many information about corona loss. In this expression, F is the frequency of supply, delta is the air density correction factor, Vp stands for operating voltage in kilovolt, V naught the critical disruptive voltage, R is the radius of the conductor, and D is the distance between two conductors. This loss is given in kilowatt per kilometer per phase. This empirical relation, as desired by Peake, has many limitations. It gives correct results only when the supply frequency lies between 25 Hz to 120 Hz. The conductor radius is greater than 0.25 centimeter, and the ratio of these Vp and V naught is greater than 1.8. Otherwise, you can also use another expression to calculate corona loss, and the expression is given by scientist Peterson, and the expression is known as Peterson's approach. This approach is not included here. You can also see this approach in many books. There are many methods to reduce corona loss. However, popularly we use three approaches. One is large diameter of conductor, second is hollow conductor, third is bundle conductor. These approaches related to the conductor and configuration of conductors. What are the disadvantages and advantages of corona in electrical transmission lines? So here we have a slide showing a comparative study. We can see there are some advantages of corona as well. The diameter of conductor increases due to ionization of the surrounding air of the conductor. Second, it helps in reducing electric stress between the conductors. Third, it also helps in reducing transient effects produced by the surges. So these are some advantages of corona. However, there are many disadvantages, such as corona loss reduces the efficiency of transmission line. It also produces ozone, and that ozone leads corrosion of conductor's surface. Further, it also introduces radio and TV interference, which is not at all desirable. Further, it is also harmful for line insulation. It also produces harmonics in transmission line. Always apply WWH, what, why, and how to learn more and more and in depth knowledge. Please don't restrict yourself here. Keep searching and reading of suitable contents of your need. Thank you.